Okay, now I want to talk about validity. Validity. In other words, control. We're going to be talking about control. And what does control refer to? This chance business that the presumption is, and the danger is, of course, in any kind of research or any kind of investigation, that the results that you come up with are not due to the cause-effect relationship you're thinking about, the dependent-independent variable relationship you're studying or hypothesizing or thinking about. Instead, it's due to some factor that you have overlooked. We call that chance, something that you're not aware of, that you have no control over. And the term validity and internal validity specifically both refer to the ability to state that and conclude, the ability to conclude that the dependent-independent variable relationship that you have identified as the object of your research were actually studied and actually do account for the outcome, that independent-dependent variable relationship. In other words, there are two kinds of validity that we refer to first with reference to scientific research. That again is internal validity, and as I said, it refers to the question: is the dependent-independent variable relationship identified truly responsible for results? The slide that I'm talking on top of misspells, it says dependent variable relationship, and I'm too lazy right now to retype it, so please make a note. Is the independent-dependent variable relationship truly responsible for results? There's another kind of validity in the domain of scientific research, external validity, and that relates to being able to conclude that findings of your study can be generalized. Keep in mind that when you do research, you're usually not interested in just studying one thing at one point in time and saying, well, this dependent-independent variable relationship, this effect that I have found, only applies to this one set of participants that I'm studying and might be interesting, but forget it. It doesn't apply to anybody else. In speech-language pathology, certainly, would be nice if the treatment that we looked at and found had a influence on an outcome, on a dependent variable, led to some kind of an outcome, could be maybe generalized. Maybe we could presume that it would apply not only in my research lab, but also clinically, maybe in the field, as people do therapy out there. They could apply my results. If we find, even in a quasi-experimental study, that children with SLI have issues with dissemblance, let's say, we can apply that not just to that little group of kids with SLI that we did our study on, but then maybe presume that that is an issue that we should examine clinically in the field. So external validity refers to the question, can findings be generalized? And whenever we do research, we typically want our findings to apply to more than the sample population that we're evaluating, but that we would like the findings to apply to the full population that the sample represents. You're following me on that? Now we're going to focus in on internal validity and issues that we need to control. And that's the term that's used, control, which applies to, we do things to reduce the chance that chance variables, reduce the probability that chance variables that we have no control over, are accounting for our results. We'll do a lot of things. We'll do the best we can to control for things and assure internal validity. Now, I would like to briefly refer to the kinds of error types that we're trying to guard against as we impose controls in our research, and as we impose controls in our research and try to assure that it's the independent variable relationship that we're studying, that we're manipulating, that really is accounting for the outcome. So the faulty rejection of the null hypothesis. Recall this weird point that I think I made early on, that the presumption of the scientific community when one does research is that results are not due to the dependent-independent variable the researcher identifies. We say then that in order to indicate that we understand this position of the scientific community, and that we are operating within the parameters of skepticism established by the scientific community, we state a null hypothesis. We predict that treatment that we are studying will not have an effect on the outcome. There will be no significant difference between the experimental and the control group following treatment, following manipulation of the independent variable. There'll be no effect. But we want there to be effect, so we would like to reject that null hypothesis. We would like to reject, at the end of the day, at the end of the study, the null hypothesis that the independent variable that we're studying is not going to have an effect. We'd like to say that cueing, for example, and causing having a child repeat behavior and correct for error will have an effect, but we will say initially it does not. And then we will try to reject our null hypothesis. But it would be a mistake if we rejected the null hypothesis when in fact results were due to chance. That is, we actually did not, at the very end of the day, did not. We may have claimed that there was a significant difference between the control and experimental group, but we would have done, if we do that in error, and there really isn't, that something else got in the way, then we will have a faulty rejection of the null hypothesis. That is, results would have been done due to chance and not due to the dependent-independent variable, that we may conclude somehow, we may have concluded that we've supported we may conclude erroneously that we supported our dependent-independent variable relationship. We want to avoid rejecting that null hypothesis prematurely. Type 2 error type is faulty acceptance of the null hypothesis. That would be a unfortunate thing, that at the end of our study we say ultimately, oh yeah, results were due to chance, just like we predicted to begin with. Results are due to chance. Whoops, we failed. When in fact you succeeded. But somehow you overlooked, you did some analysis of the, you made some analysis of your data that led you to accept the null hypothesis, accept that results were due to chance, give up, when in fact you succeeded in your research. You won't want that either. I hope you're following that a little bit. In any event, let's look at different factors that we need to control to assure internal validity, and that is to ultimately that will put us in a position to actually appropriately reject the null hypothesis. That's what we want to do. Reject that null hypothesis. Internal validity. That is, they could lead to chance variables playing a role in results. And we want to get rid of as many chance variables as we can so we can safely reject the null hypothesis. That's what we want to do. And say that results were due to our dependent-independent variable relationship. So let's look. Number one, subject selection. You want to make sure that there is not something about the subjects that are being selected. I'm using the term subject selection. I think that term stands, although we call everybody now participants. So perhaps I should have rewritten this as participant selections. Check your textbook, but I think they still use the term subject selection. But think about it. You could just say if you have, again, the best way to select subjects for your various groups that you're studying is random assignment out of a single pool. But if that's not possible, or that's not the design of your study, if you have two separate or different groups of subjects, well, you want to make sure that there's not something about one or the other group that will influence the outcome. For example, I for a long time for a while in any event, did a constructivist type of program. I consulted to preschools in Staten Island, working with kids with autistic spectrum disorder. And I used a Greenspan type approach and my own type approach, which involved engaging the children in play and problem solving, and working with reference to the child's intent and interests. Even when those interests, by the way, were unusual or not typical. If you know kids with autistic spectrum disorder, you know that they do some things that look not typical, atypical. That's besides the point. So just say I wanted to look at the influence of problem-solving play intervention on vocabulary development in children with autism. So I do the research in the school that I consulted to, and I even do an actual experiment. So I take a group of children in that particular school, and assign some to the experimental group and some to a control group. Some get my treatment, some do not get my treatment, but get typical, maybe even operant treatment instead. I find that my group does significantly better than the control group at the very end. That might suggest that that my approach is that problem-solving play is the independent variable that, as an independent variable, it is effective in leading to in influencing vocabulary development in this population. But as it turned out, there might be another hidden factor if I wasn't careful about subject selection here, a hidden factor, and that is the following. The parents of the kids in the schools that I consulted with usually approved of my interventions. And many parents who did not like my program moved their kids actually out of the school because they wanted applied behavior analysis interventions. So I had a select group of parents who, after I did the treatment, they followed up. They did a lot of follow-up at home. So the kids were getting a lot of additional time in my doing my treatment because they were in a select school where the parents selected themselves for involvement. Now, I didn't say I was studying parent involvement in the treatment. I said it was the treatment I was studying. But there was another variable there, parent involvement. And that was something I did not control for, if you're following me, by doing the study only in one school. And so that subject selection decision I made could have influenced the outcome, because it may not have been play alone in any event that led to the positive outcome, but instead parent involvement, if you're following me, a variable I did not explicitly say I was studying. Subject selection, therefore, is a factor in an important factor in that needs to be controlled to assure internal validity. History is a second factor, and that refers to what happened in, again, it's a component, partly a component of subject selection and partly a component of the actual research itself, particularly if the research is longitudinal. In terms of subject selection, you want subjects to have similar, or participants, I'm sorry, I'm calling them subjects, I don't think I'll ever get away from that. Participants to have a similar, if you're matching them in any way, if they're supposed to represent a population, you don't want their history to influence the history of subjects in one group or another to be a potential influence. Just say you choose a set of, assign a group of subjects to the experimental group, assign a group of subjects to the control group. And during a longitudinal experiment, there were a lot of divorces, say, in one of the two groups. Separations, caregiver separations. At the end of the day, the performance of those children in that group, the children in the group who experience separation, may be different from the other group because of the history of parental separation or parental illness, perhaps in another situation. Or if you do not randomly assign, but instead select subjects, participants from two separate groups, and that's really a problem in quasi-experimental research. You do your best, let's say, to match kids with learning disability, SLI, with kids who are typically achieving, matched for performance on one test or another, age, grade, whatever. As hard as you match them, kids with SLI may have different experiences than typically achieving kids. Maybe kids make fun of them sometimes. Maybe they know that they have a disability, and their knowledge of their disability contributes to performance. History is a possible factor that can influence internal validity, and that needs to be controlled. Maturation is another factor. Maturation refers to the fact that particularly in a longitudinal study, subjects get older while you perform a treatment. And a child who is language delayed or who has a problem, and just the act of getting older and having more experiences over time could lead to the outcome, or just getting older. Neurologically, they mature. Individuals mature. That could lead to an outcome. The outcome that you're claiming is due to the treatment that you're providing. Now, how do you control for, just quickly ask the question, how do you think you can control for maturation? Yeah, well, if you have an experimental group and a control group, and both groups come from the same pool, and both groups are getting older over time, then you're controlling for maturation by having an experimental and a control group, because both groups age, and therefore you've controlled for aging. It's occurring in both groups. Think about that. Instrumentation is in my opinion, number one factor. Well, that's a silly thing to say, I guess, but is a critical factor that needs to be controlled to assure internal validity. Instrumentation. What is instrumentation? On one hand, I'm sure you've heard some of this in other courses, I am sure. And instrumentation is typically refers to instruments like computers or audiological equipment, and it involves the appropriate calibration and functioning of equipment that's used, technological equipment that's used in research. So if you're presenting stimuli to subjects in a study, if you're evaluating the effect of something on hearing level or the effect of hearing level on something, a hearing impairment, you need to have your audiometer properly calibrated, or else the chance variable of your subject descriptions are going to be skewed, right? The level of hearing impairment, say, or if you're presenting data or stimuli through a computer system or some other piece of equipment, and the piece of equipment is not working as you're claiming, then something besides the treatment is going to be influencing results, a chance variable coming from the equipment. However, and we're going to come back to instrumentation, instrumentation is more than physical technological equipment. Instrumentation is anything that you're using to measure behavior. Use of standard and non-standard assessment procedures. Standard norm reference assessment instruments, such as the clinical evaluation of language functions, the SELF, the P-body picture vocabulary test, the one-word picture vocabulary test, receptive and expressive, preschool language scale, etc. Those assessment instruments are typically used as pre or post tests to evaluate the effect of a treatment on a dependent variable. The dependent variable is measured some way. Sometimes it's measured by a non-standard assessment instrument, such as the Bloom and Leahy evaluation procedures, or Brown's morpheme analysis procedures, etc. Those instruments, the SELF, the PLS, the one-word picture vocabulary test, receptive and expressive, the P-body picture vocabulary test, those are potential sources of threats to internal validity. How so? Well, just say the assessment instrument is culture biased. Just say it wasn't normed on the population that you're studying or some of that population. Well, culture bias introduces a chance variable. Culture bias, or the aspects of the design of that assessment that are biased. Just say the instrument it claims to be a language test or a test of the thing, an assessment of the thing that is your dependent variable. But it doesn't have its own validity. It doesn't have construct validity. It's not really a measurement of what it claims to be a measurement of. You've introduced a chance variable. Instrumentation is a very important thing that needs to be itself controlled carefully. We're gonna spend some time with instrumentation here again next week. But let me stress that. Now, you know what another instrument is? It's a human being. It's a judge. Judges, when somebody is making a judgment, and that judgment is a part of the way you're operationalizing your dependent variable, the person who's the judge can be a threat to internal validity, because the judge could be biased, or the judge, the evaluation of the behavior could be somehow off. Take, for example, just say you're doing, again, a play treatment. Let's say a play treatment with kids with autistic spectrum disorder, and the influence on the development of content categories. Content categories. Categories of ideas that the children express. And you're using the Leahy assessment instrument, the non-standard Leahy assessment instrument, as the way you're operationalizing language performance. Language performance in a naturalistic setting. Well, you're all doing a language sample for your 602 language acquisition course, aren't you? Right, and the language sampling, if you remember how you're doing it, you're collecting 100 utterances, and each utterance you're making a decision. What category of ideas does the utterance go to? There's some aspect of subjectivity in that decision, and it's sometimes quite confusing. If you remember, when there's a coordinated content category in a sentence, for example, this is a black cat. Do you make that sentence existence? Do you make that sentence attribution as the verb relation, as belonging to which is the verb relation content category there? And by the way, how do you handle the other one? You following me? That could be confusing. So thus, controls need to be put into place to account for the human instrument that's making the judgment. We'll look at that a little later on, and we'll see that a reliability study has to be done to make sure that the judges are reliable, because a judge can be a source of instrumentation interference and ultimately chance variance. That is a source of chance in the data. Another factor influencing internal validity is mortality. That is, mortality refers to subjects dropping out of your study as you do your research. And if you're doing a study over time, a longitudinal study, sometimes subjects drop out. And if there's a selectivity in the dropout, if the dropout isn't random, but instead perhaps I again do a study of play intervention with kids with autistic spectrum disorder, influence of play on language or vocabulary development, and 5 kids drop out. Perhaps those 5 kids were kids of parents who don't like play intervention. They want operant intervention, so they pull the kids. Or these are kids who are not enjoying, they're not doing well, and the parents pull them. Well, you've had a selective removal of subjects, and whatever behavioral characteristic contributed to the mortality may be a contributing factor, maybe a variable itself that's accounting for the outcome. Thus, mortality is another factor that needs to be controlled. Test practice effects. We do different evaluations when we do repeated measures. We have to make control. we have to institute controls for repeated measures, because simply the act of taking a test multiple times or being evaluated multiple times, even if it's not a test, even if someone is simply observing a child's behavior multiple times, say once a month, you're observing a child and doing a Leahy analysis, which simply, again, involves collecting data at a particular time, videotaping or something. The act of being videotaped, the act of being observed multiple times, that is a testing effect that could influence your outcome. It's a potential source of chance variance, the kid's reaction to being tested. Or if the same assessment is being given to a child multiple times, experience with that assessment, that could be the factor that is influencing results. That would be a chance factor, a factor that's overlooked. That would be something besides your dependent-independent variable relationship that's got to be controlled. And an interaction of any or any factors, that the way factors interact in a treatment that you have overlooked, that you're not studying, the interaction of factors. Say play and the personality of the adult, or the a way that the adult is speaking to a child, as well as the actual variable, the treatment variable that's been identified, the interaction. That could be influencing outcome, and therefore that's something that needs to be controlled. That's as far as I'm going today, right now. What I'm going to do is return to instrumentation and get into reliability and validity as it applies to assessment instruments, and see how we have to really pay attention to the assessment instruments that we're using. The instruments that we're using to operationalize are dependent variable. We have to pay attention to that in research and in our clinical work too. We have to be very careful to pay attention to how assessment instruments that we're using to evaluate whether our treatment is being effective, whether a child who is receiving treatment truly has a disability, or perhaps does not have a disability and has been misevaluated. We have to look at our assessment instruments. So that is what we are going to do next time.